In terms of sheer numbers, the AC induction motor is the most widely used type of electric motor in the modern world. AC motors are primarily used as a source of constant speed mechanical power, but are increasingly being used in variable speed control applications. After studying this chapter, you should be able to describe the characteristics of single-phase AC and three-phase AC motors. Understand the principles of operation of the AC induction motor. Explain how single-phase induction motors are started, including the concept of run and start windings and start capacitors. Explain how to reverse the two-phase split-phase motor. Understand the principles of operation of the synchronous motor. Describe the concept of power factor and power factor correction, and understand the principles of AC motor control, including start-stop control, jogging, reduced voltage starting, and variable speed control with a DC link converter. AC motors are popular because they can provide rotary power with high efficiency, low maintenance, and exceptional reliability, all at relatively low cost. These desirable qualities are the result of two factors. AC motors can use the AC power right off the lines. DC motors require the added expense of a rectifier circuit, and most AC motors do not need brushes, as DC motors do. In most cases, the AC power is connected only to the motor's stationary field windings. The rotor gets its power by electromagnetic induction, a process that does not require physical electrical contact. Maintenance is reduced because brushes do not have to be periodically replaced. Also, the motor tends to be more reliable and last longer because there are fewer parts to go wrong and there is no brush dust to contaminate the bearings or windings. Despite these advantages, there is a problem with using AC motors in control systems. These high-efficiency AC motors are by nature constant speed, and control systems usually require the motor speed to be controllable. As you recall, the speed of a DC motor can be controlled by simply adjusting the applied voltage. For complete speed control of an AC motor, both voltage and frequency must be adjusted, which requires using special electronic speed control circuitry, such as the volts per hertz drive or the vector drive discussed later in this chapter. Still, the most common use of AC motors is for many applications where speed control is not necessary. Including here are fans, pumps, mixers, machine tools, hydraulic power supplies, and household appliances, to name but a few. Like DC motors, AC motors come in all sizes. Integral horsepower motors are those with a power rating of up to 1 horsepower to over 10,000 horsepower. And fractional horsepower motors are those rated less than 1 horsepower. Typically, the larger motors use three-phase AC power with voltages from 208 to 11,000 volts AC, and the smaller motors use single-phase AC power with either 120 volts or 240 volts AC. There are a number of different types of AC motors. The most common by far is the general-purpose induction motor, which is the familiar type found in major applications and in machine shops. Other types of AC motors include the synchronous motor, the AC servo motor, and the universal motor. Before looking at AC motors, let's review AC power.